Hello everyone, a very good afternoon. Welcome to the live session of Ask the Expert event exclusively for the members of Payatu's community. The aim of this event is to equip you with comprehensive and valuable insights into cybersecurity. My name is Aparna and I'll be your host for today. Before we dive in, let me take a few minutes to introduce Payatu. Payatu is a research-driven cybersecurity consulting firm with a decade-long focus exclusively on cybersecurity. This is an overview of the various consulting assessments we are known for across the globe. We have delivered various cyber talks and workshops at prestigious security conferences, including Black Hat and DEF CON. We take pride in our decade-long impact on the global cybersecurity community. That was a brief introduction to Payatu. Today, our bandit Samuel and Meera, Payatu's security consultants, will be answering your questions on Docker and Kubernetes security. Before I hand it over to them, here are a few housekeeping tips. Please remain on mute. If you have a question, type it in the chat box. Our experts will address your questions one by one. Also, guys, while Samuel and Meera are taking up questions that you have listed, that you have submitted in the form, I request you all to drop your questions regarding the same in the chat box. Without further ado, let's get started.
Hey guys, hi, thank you for joining in. Myself, Samuel Valmiki, a security bandit at Payatu. I am having a current experience of 3.5 years in the cybersecurity space. Initially, I started with bug bounty and stuff. And prior to, I am currently working in the web tower. I am also involved in of mobile testings as well, source code review, and a lot of other stuffs. Mostly, I have developed an interest lately in DevOps, trying to learn cloud security, how it works in the backend, and a lot of stuff. Also, actively, I have been involved in bug bounty huntings, submitted reports to companies like Apple, Zomato, uh, Grofers, Freshworks, and a lot of other companies. This is something that I do in my free time. I am based out of Mumbai, and currently I am also involved in an active research on Web3. This is kind of an interest developed due to the industry kind of the standards that are going on and the interest that is going on in the industry. I'm trying to figure out Web3 with smart contracts, with vulnerable contracts, trying to build vulnerable contracts and trying to figure out and read source codes and find bugs into that. Also, you can also see the Twitter handle that I have. I keep sharing useful tips and tricks, also sharing whatever I learn in my due process as well. Also, you can follow me on Twitter, LinkedIn, both. I'm actively involved in sharing to the community over there. At Payatu, we have got a chance to research on Docker and Kubernetes security, and this is a session on the same. I have my teammate Meera Patel with me, which will be looking over the Docker questions that are from the community. Over to you, Meera.
Yeah. Yes, Samuel. Thanks for the intro. All right. Yeah. So hi everyone, it's Meera over here. So I have overall experience of 3 years in the cybersecurity field, mostly on application security, where I have covered web application security, API, and network pen test. And other than that, I have done some null meetups and some speech. So I have been a speaker as a blockchain and smart contract security. So where I have showcased some of the smart contracts and also the demo of how to look forward to the vulnerabilities inside the smart contract. And also, just like Samuel said, I'm also interested in Web3 and researching on the same, learning more into it, and trying best to provide the same to the community. And today we're gonna continue with the Docker pen test, or I mean to say Docker security sessions. And also feel free to ask questions just with the sessions are going through. Yeah. All right. So let's start with the first question that is more demanding from the community side. The first question is regarding the roadmap of how to start Docker or Kubernetes security, and moreover, like how to learn it. So first thing we need to cover is the basic part of the Docker. And when we talk about the Docker, it's about the components and how that particular technology works. Likewise, for the Kubernetes, we need to do the same. We need to learn what all components are being used in the Kubernetes. And other than that, when we talk about the strategy, how to learn that, right? So just by learning Docker, it's not enough, right? So we need to create some vulnerable labs, and also we need to have some pen test machines just to understand how it's working when it comes to security part of the Docker. Same way we have for the Kubernetes. So it's better to understand more about the technical part of the same and also to recreate the same thing. And we have some more things to be sharing in the end of the session. That's about the resource part from where you guys can look forward about how to start with the Docker and Kubernetes security. Let's move on to the another question. So this is one of the question most people are confused about. What's the difference between the virtualization and Docker? So when I talk about the virtualization, if we guys are known about it, so whenever we use any of the software, right? So while running any software or any code, we end up with some libraries or any code dependencies. So in Docker, it's not the same. So Docker eliminates that kind of a thing. So when I talk about the dependency part, Docker itself has those things. Just like we talk about the image file, it contains the code, the libraries to be used in the containers. And also another part is about the hardware cost. So when we talk about the Docker, it's running on the host operating system, not like the virtualization where it was using the hardware level. So in the Docker, we are most of using the host operating system where all the containers are running on top of it. So there is no hardware cost for that because it's on the host. Other than that, when we talk about the containers, it's moreover isolated. Also depends on what kind of a security we have provided to the each and every containers. There are some security issues which we wanna discuss, but we can say that we still have this isolated environment out of where host operating system is also safe if the containers are secure. Let's go with the another question. So this is about the Docker components. So what is Docker? What all things are inside it, right? So we can see at the left side, it's about the host. And over here, we can see the client. That's the Docker command line we can think of right now. And in the right side, it's about the registry. So when we take about the Docker registry, it's moreover about the example of Docker Hub, where all the images are saved inside it. So if you want to use this particular image, so there are two kind of images. One is verified, another is unverified. Unverified are the ones which are gonna be trouble. So we're gonna discuss that in the security topic. Here, when we pull a particular image, we can run it, and the same while running it, the API call gonna be created. That's the daemon API, which is a unique socket. In technical terms, if we call is when we initialize Unix socket, it's docker.sock, and it goes to this particular host, and the container is being run. So when you talk about container, it's about the base image. We can choose any image like Ubuntu or any operating system that we need. Other than that, the code we need inside it, and also the settings or configurations with it, right? So when I talk about the first step, it's about the Docker file. Whatever we mention in the Docker file, we can build it. Once we build that particular image, we can run it as a container. So this can be done two-side. Either we can use predefined images, or else we can create our own and then run it. All right, so next concept is about namespaces and C groups. So what are this in the Docker and how it helps us, even if we think it as a perspective of a security, right? So the namespace, what it does is isolates all the processes in the system, right? So when I talk about the host, when we talk about host and containers, right? So when I initialize a container, I need the process to be different from the host operating system. So that's why we have this namespaces, which divides it from the host operating system. So here we have this first PID, that is the process namespace. So if I talk about host machines are having multiple processes running, right? If I want none of that but multiple process to be carried again inside a container, right, while running it, I can mention it as a none. And if I want any of the process ID out of from the host side, I can add that too. Likewise, it's about the network. If I want my container should have its own network, right? So I can create one of the bridge network and then assign it over here as a my bridge. Or likewise, if I'm interested to use host host network inside my container, that can be done. That's not a good practice, but people do sometimes. Last is about the user namespace. So when we talk about user ID, group IDs, that is in the host machine, right? So same things if it's not needed in the container, we need a different user ID and group ID. Even if we think of from the security perspective, the container is compromised, right? So at that time, we can think of like, even if something happens to the container, it won't affect the host system because of just by using this user namespace, because the user ID and group ID is different than the host machine. So just like namespace, we have the C groups. So in the C groups, we limit the resources. That means we allocate the resources, whether it's memory or CPU, to the containers. So here we have this command. Likewise, there are more commands about this C groups, how to assign it. And here we are assigning a CPU limit of 0.5 to a particular container. Likewise, we have multiple containers in real life scenario in organization. So we can assign those to each and every containers. So this is one of the thing. And when we talk about namespace and C groups, these are already inbuilt feature of Docker. So we don't need to add anything extra or install anything extra with it. All right, so next move on to the next question. It's about the Docker orchestration and the beneficial it has on the organization. Yeah. So let's understand what is Docker orchestration. Why do we need that? And till now, we were thinking of a particular one host machine which has multiple containers, right? But now the scenario is about different host machines. On right now, just take this node one as a first one host machine, node two as another host machine. Likewise, in organization, we have multiple host machines which under which containers are running on each and every host machine. If I want to connect this, it happens in the overlay network, which we're gonna cover in next slide itself about the overlay network. So we can think of this is the manager. So when we talk about Docker orchestration, there is one tool called Docker Swarm, inside which this is the manager which manages each and every container. What if I want this node 2, that is the host 2? It's going under the patch part or any update part, right? So I can manage it. I can take a downtime of this and it won't affect the node 1. I can have a backup of it. Many things can be done from the Docker Swarm. So this is a plus advantage where I can manage all the multiple containers from the Docker Swarm. Okay, so next is about the Docker networking. So what all kind of security issues it can provoke, right? Basis of what I choose. So the first one is about the bridge. So if our Docker container is on a bridge, it's different from the host. It's not using any host network. But at the same time, if the bridge network is being used by multiple containers, if it gets compromised, then multiple containers can also be compromised at the same time. When we talk about the host, so it's the most dangerous one. We should not go with this practice, because here it's assigning directly to our Docker container. And if one of the container, if it compromises, right, so the host machine also gets compromised with it. When I talk about the none, it's the best practice if you don't need access to the internet, right? So none is when none of the network has been assigned. Just we can think of the demilitarized zone in, like, we have a servers, right, in the organization which are not connected to the any network. So here none it can be used over that time. Last is the overlay. So when we were discussing about the Docker Swarm, right? So the overlay network is used when multiple hosts we want to connect with each other. And also overlay is good if we are having a network policy and firewalls in place. If that is not being properly followed, then it's gonna create an issue and multiple hosts can be compromised with it. So again, it depends on how we are using this Docker networks. All right, so next question we have is about the Docker pen test. So there are many things comes to our mind, like to follow any particular thing or any guidelines for the Docker pen test, right? So the first most thing comes as the defining scope. When I talk about defining scope, it's about the internal pen test, whether it's external pen test or internal pen test, right? So when we talk about internal pen test, there are many things like host configurations to be checked or Docker daemon file configurations. there can be any misconfigurations or sensitive information exposed in this kind of a files. And when we take a scenario from the external pen test, right? So there can be an instance, a particular IP with a port of Docker 2375 exposed in the internet. While running through the Nmap scan, we can see a particular instances exposed. So while accessing this particular API, there can be scenarios where this particular instance has privilege or multiple configurations set to it. Sometimes I have been through some of the sensitive information being leaked in the environment files. So we can access that from the external pen test, or else another thing is I can call this particular API and create another container with the full privilege. So those kind of a things can also be done. So this is two kind of a scenario, whether it's internal or external pen test. We need to understand that. Based on that, we can go with. Later on, we can go with the vulnerabilities in the Docker images. So there are some of the scanners that we're gonna discuss about the Docker vulnerability scan. So we also need to go through the Docker images and containers if it has any vulnerabilities inside it. And if we get any kind of a vulnerability, then we gonna focus on the exploit part of the same. So we again gonna continue with the exploit. So we can again gonna continue again the exploit part in the upcoming slides. And when we talk about the post exploitation, it's about the persistent access, or as we can think of lateral movements that can be done in the same thing, right? All right. So next we have is the common security risk related to the Docker. So as we discussed, either it can be a configuration issues, like some of the things which are misconfigured inside a container, which is not checked while code reviewing or in the audit process. Another is non-trusted images, like we are unaware about what kind of an image or what kind of a things are inside that image, and we are still running it as a container. So this is again gonna be an issue. And another thing is about the, so if containers are having full privileges and then we are running in the production environment, again, it's going to be an issue because we can have the container escape part, which we going to discuss just after this. So these are some of the risks. Other than that, there are many. We can think of any sensitive information disclosure, credentials inside the image, right? So while we go for the vulnerability scanners, we can get those things. All right, so let's discuss about the Docker container escape, what it is. While thinking of the scenario, let's take it as it's once we get access to the container, right? Like we have exploited any vulnerability and got access inside a container. So after that, how we can get access to the host machine? That's what Docker container escape is. So getting access from the container to the host is the steps that we're gonna now understand. So there are different kind of methods. Most famous methods I have just mentioned over here right now. So when we talk about the Docker socket, so it's a unique socket which provides internet access, right? So when I talk, if I get access to a container as an attacker, most of the times it doesn't have any internet access. It doesn't need, because the services whichever are running is already predefined over there. So Docker socket, if it's assigned to a container, means I have internet access inside that container. I can download a new image, I can make that image run, or I can provide a privilege and run a new container inside it. And then while running a new container inside it, I can do anything. I can provide a full privilege, or I can assign a host file system into that new container and get access to the host main file system, root file systems of it. Likewise, we have another one is the host mounting. This is directly where I can just mount the main file system to the containers, and then later on we can apply a chroot. So what is chroot is just like we have a directory where we have a root access, right? So just like that, if I get access to a container and I can assign the host file system to that container, and I need a root access to that particular folder, I can apply the chroot part. Another is about the privileged containers. So when I talk about privileged containers, it's all about the kernel modules, the superpower we can say of all of the privileges, whether it's related to system admin roles or network roles, network administrator roles, everything, if it's assigned to a container, right? And that container is being run. So this is again a biggest flaw, biggest issue. So for that, we have some things to be checked. We can check for the capabilities that is being run. We have some commands cap sh. From there, you can have an access like what all privileges are provided. On that basis, you can mount or do anything based on that. So these are some of the Docker container escape, because when you talk about pen test, getting inside a container, getting some sensitive details is not the only goal, right? We are aiming for some more. We are aiming for the host machines, or after that, we are aiming for exactly more host machines connected with it. So lateral movement part also. All right. So the next question is about the how our organization ensures that Docker images are secure. So what all things can be done and what all things to be followed. So first of all, we need to use the trusted source, the images, right? So we don't need we have this verified symbol inside each and every image in the Docker Hub, if we talk about. So we need to use the trusted sources, and also it's a plus point if we run a vulnerability scanner on that particular images, just to understand what all things are inside it, whether it's properly configured, whether there is anything sensitive information or inside it. Or think of a based image, right? If you are using any base image or anything that you are calling as an image, if it's vulnerable, so how come we'll get to know, right? So from the vulnerability scanner, we'll get to know of that, and we'll also understand that outdated packages are inside that or not, right? Other than that, as we discussed, it's about the sensitive data. Most of the times we are getting these things even in the Docker Pentest part. Any environment files or those kind of things, developers are not aware most of the times, and they do forget to clear it out. And we get some credentials or API keys or those kind of things inside a Docker images. And there is this really a good blog of Docker security best practices from one of my friend. He's Desi. You guys can have a look about it. There is a good methodology of how to secure a particular Docker image. Oh. So this is again most demanded question, I would say, about the Docker security scanner. And also one of the person has asked about the to guide a flow of automation, how to have this container security scan for vulnerabilities, right? So if I am focusing, or our organization is focusing for CIS benchmark to be met while having this vulnerability scannings, right? So we can go with the Docker bench, which is a script which is totally related to the CIS benchmark. And another we have this, if I just want to go with the image scanning, right? So Treeway is one of the tool which goes for the vulnerability scanners. These are the inbuilt tools AppArmor SE Linux. So these are inbuilt kernel Linux tool, which would help us understand what all privileges or what all configurations are provided to the host system and the containers. This would help us in that. These are again an inbuilt tool. And last one is about the SecCom. This is again an inbuilt tool, but moreover, it's about what all system calls can be made by the kernel. So this it checks for. So these are four of the tools. And if we talk about how we can uh, bring these things in an automation way, right? So from the developer's perspective, I would say while running the tools, we can add this as a CI/CD pipeline and integrate these things, whichever suits us, right? If I'm just aiming for image scanning, I'll go with Trivi. If I'm aiming for any CIS benchmark or auditing, I'll go with the Docker bench. And one more thing is that we are having this new things rolling out in Payatu blog website. It's about the Docker and Kubernetes pen test methodology with step-by-step commands and pen testing, how to do it. Other than that, reporting part and everything. So stay tuned regarding that too. Yeah. So yeah, I would like to hand over the next thing to the Samuel for covering the Kubernetes session. Thank you.
So Kubernetes. So Docker in the later end comes up to Kubernetes. What is Kubernetes? Kubernetes, just let's go with the summary of what Kubernetes is. Kubernetes is just a orchestration tool. It's kind of a manager for all other containers that you might build. So if you are in an organization, you might have a lot of containers running at simultaneously at one particular time. So to manage all these at one time, Kubernetes was built. It is an open source orchestration tool which can be used for managing all these containers. It has some wonderful features like auto scaling, auto healing, and a lot of things to offer as well. And this is kind of consider this as the manager, as we have in an organization we have multiple team members working under a manager, and things are accordingly managed. So Kubernetes as that particular manager which accordingly handles workloads, accordingly handles what work needs to be done at what particular point of time. The very most question that we get is around the backbone of Kubernetes architecture. So let's understand what Kubernetes architecture looks like. Kubernetes architecture is mainly divided into two parts. First would be the master node and the worker node. Master node is also called as the control plane, where we have all the orchestration related functionality to handle every single container that we are going to launch in the cluster. So Kubernetes, when it handles a lot of containers together, it is called as a cluster. So this is called as a Kubernetes cluster orchestration tool. Let's visualize it and see how the control plane looks and the worker node looks like. So a lot of guys kind of gets confused on what is the control plane and what are the several components of the control plane doing and what are the several works of the worker node. Let's dissect it and let's look at it one by one. So API server. So API server is something that is a middleman to all the functions, all the features that are accessible in Kubernetes. Every single thing that needs to be communicated with each other is done with API server. API server is kind of a waiter between the chef and the client, and it serves whatever the admin is assigning is then sent to the worker node, and whatever the worker node has the information is again sent to the admin. That is the control plane. If we talk about controller manager is kind of the monitoring component which monitors what all containers and what all pods are there. So if you see on the right side, if y'all can see a laser over here, so this is called as a particular node. A node can have one particular container, or it can also have multiple containers running at the same time, and there can be several nodes as well in one particular several nodes as well in under one single master node. One single pod, so this is called as a pod, and one pod can have multiple containers as well as single container as well. So anything that goes over to the worker node needs to be connected with the API server. So suppose on the worker node you have an application running in a container. So what controller manager will be doing is manager will be checking in if the application is correctly running or not. If you have defined that the application should be running from 1 a.m. to 2 p.m. in the afternoon every day. So controller manager is a component that will monitor that particular time to see if that is happening correctly or not. Let's go with the scheduler. Scheduler is again a component which again contacts with the API server and then goes to the worker nodes or the pods. So what is the work of the scheduler? Scheduler is a component where API server will check what all configuration you have added. So suppose you have a configuration in Kubernetes where you have asked two particular pods to be running at the same time, and two particular pods are having two different containers running in it. So scheduler will handle it and take care of when to keep it active and when to maybe suppose you have a very large traffic amount in the afternoon, and in the night your application doesn't receive a lot traffic, and that point of time when should the application have two pods running and when should the application have one single pod running is being managed by the scheduler. Let's look at etcd. Etcd is something that looks over to the key value pair. So if you work with Kubernetes, every single thing is defined in a YAML file. So what service to use, what networks configurations to use, and what is the container to be that needs to be running, what port it should be running in. Everything is stored in key value pair, and where it is stored, and the component that manages it is etcd. So this is where the key value pair is assigned for all the values and all the configurations for the control plane. So this is about the control plane where it handles the managing of the worker nodes. Let's look at what the worker node looks like. Worker node is having three components over here. We'll be talking about kubeproxy in the next slide. Let's understand what kubelet does. Kubelet is something that is connecting with the API server, if you see the arrow as well. So if suppose I want my container to be running on this single pod, right? So I am the one that connects to the API server. API server then connects to the kubelet, and kubelet will then connect to the container runtime. This can be Docker. There can be different container runtimes as well. So consider this as Docker. And inside Docker, there would be a container that would be running. So every single pod, so this is a single pod. There are three pods, if you can see. Every single pod will have its own kubelet. Every single pod will have its own kube proxy and container runtime as well. Let's look at what kubeproxy is. Kubeproxy is a component of Kubernetes that works with handling networks within the pods. So suppose a pod needs to connect with the other pod, right? That that is handled by uh, kubeproxy. So what are the services and network services that are defined that are handled by kubeproxy? There is a link attached as well where kubernetes.io explains how kubeproxy is working. Let's visualize it as well. So suppose there is these four nodes that are running, right? So this is one particular node which has this kubeproxy. There is this client and IP tables. There is this three pods, and all these pods are running several different applications on this particular port. So initially, when you don't define anything, kubeproxy will run on IP tables. IP tables is the default selection that comes in. There are others as well, like IPVS and firmware network services as well. So we'll talk about IP tables. IP tables in kubeproxy, it identifies, so every single pod will have its own IP address assigned. So kubeproxy will then have an IP table which will have, as we have it in our Wi-Fi routers, on what connections, what requests to send to which particular clients. Our routers also maintain an IP table. So this is the same that happens in kubeproxy as well, which is then maintained by, which is then also controlled by API server. And if you have to connect to this second pod, right? So kubeproxy is the one that can help this particular node get connected to backend pod number 2. Um, let's move on to the next question, which says about, in case of increased traffic, how would we scale an application to handle an increased load? This is something that happens a lot when in an initial stage, if auto scaling is not properly configured, an increased load can hamper a lot of application accessibility issues. So there is where we kind of introduce the topic HPA and VPA, which stands for horizontal pod autoscaler and vertical pod autoscaler. So what happens when we get an increased load? This happens a lot of time and a lot of scenarios. So in that particular point of time, you need to identify the main identify. You have to analyze where the issue lies. First of all, to identify, right, whether you have to go for HPA or whether you have to go for VPA, you need to check if the issue is related to CPU and memory. Then you would have to go with horizontal scaling. What I mean by that is, suppose there is one particular pod running, right? Let's visualize it in this way. So suppose this is one particular pod. This is an example for HPA. One particular pod which is running, and this can handle 10 requests at a time. And suppose your application is getting 20 requests at a time. At that time, this particular pod won't be able to handle it, right? Because this doesn't have that much of resources available there. is where horizontal pod auto scaling comes into place, where there are a set of rules defined where it says the if the resource is not sufficient, and if the load is increasing to that bit, we can auto scale. So what Kubernetes will do is, we don't need to do anything manually. We don't need to go and create several pods for the 10 request, extra 10 requests that is there. We can directly add it in the Kubernetes auto scaling feature, and Kubernetes itself will take care of this and create two more pods. What will this do is, that will then whatever 10 requests that came in extra, that will be distributed to the pods as well. Same goes for vertical scaling as well. Vertical scaling is where the resources like the CPU and the memory, right? Suppose this particular pod which was created had 1 GB of RAM, and suppose CPU, 2 core of CPUs, but your application handling 10 requests only needed 500 megabytes of RAM, and maybe just 1 core of CPU, right? In that in that point of time, what a vertical pod auto scaling will do is, it will then decrease the size accordingly and increase as well. So in the diagram, as you can see, if there is a resource kind of a resource heavy content that is going on, and the CPU was initially on 100 and the memory was on 100, when there is a resource load, what vertical pod will do, it will increase accordingly, and vertical pod will also decrease accordingly if there is no need of that extra resources that is been consumed by the container or the pod. I hope this is clear. Let's move on to the next question. This is kind of a question where people are not clear on what happens when a master or a worker node fails. So I want you all guys to comment in the chat on what do you think on when a master node fails or a single worker node fails. What do you think will happen? Uh, we can have it on the chat. If a master node fails, will any of the other components be affected? Any curious learners who want to just guess if a master node is failing? So the architecture we looked at, right? Suppose there was some technical error and the master node failed. What about the worker node? Will it still be working or not? Correct. Gautam, you are absolutely right. So in case of when the master node fails, the worker nodes are not affected at all. The worker node keeps on running, but the only thing that happens is you won't be able to manage the pods anymore, because your the control plane where the actual control management was happening, that has failed. Same goes for the worker node. If a particular worker node fails, suppose in a failure of a DNS request, what happens? The master node keeps on running. There isn't an issue with the master node. Kubernetes has this feature of auto healing as well, where it tries to kind of figure out the issue and tries to restart the server. If there was kind of a technical glitch or something, it will try to restart the pod, the worker node, which should kind of remediate it. Who handles this to see if it is running on a particular time or not? So the scheduler ensures an uninterrupted service and availability of every single pods. So suppose a worker node has failed, Kubernetes has this feeling of auto healing, that it will take the components of that particular worker node and it will create another healthy worker node and deploy all your content over there and make sure accessibilities are not affected. Uh, yeah. Moving on to the next question, what is the work of Ingress is in Kubernetes? Ingress is something that you might have heard a lot while handling Kubernetes or Pentesting, or maybe even the deployment phase. Ingress is a resource that defines rule to expose services to external traffic. So what is Ingress? Like we have our kube proxies inside our pods to communicate internally with the pods. Ingress is something that helps these kind of things, the networkings and everything, onto the external point. just not handling other things. It routes, it load balances, it has several other features as well, like SSL termination, name based virtual hosting and stuff like that. What this helps is in, suppose you have these two nodes running, right? So there is these four pods that are running separately, and you have an ingress controller over here where you have defined the name blue and green, which you can see over here. This is kind of an external network that is coming in, and you have this path blue and path green. So if a user is hitting path blue, it will go to this particular service. Ingress will dynamically send this to this particular blue service, and the blue service running on port 8080 will then connect to pod 1 and pod 3. Same goes for the green service as well. So these are called as services in kind of the middleman which handles the coming and going of networks are called as services. So same goes for green. If the path is green, it will take the name as the service name as green running on 1990, and it will then redirect it to port 2 and 4. So Ingress is kind of a tool that helps routing, that helps with several other features like load balancing from an external perspective to the clusters and the pods that are running in the Kubernetes clusters. Also, types of Kubernetes. These are some very basic fundamental questions which a lot of us get confused in maybe, and not having this concept clear can create an issue going on further as well. So we have these four main types of services that are in the Kubernetes orchestration tool. There is cluster IP, node port, load balancer, and external name. So let's visualize it directly and look at it what happens. So cluster IP. Cluster IP is something that every single cluster is assigned an internal IP address. Internal IP address will only help it connect with internal clusters. So cluster IP, when we go with cluster IP, this is where the nodes will only be able to connect to each other in the cluster, and the user also, if the user wants to connect to one of the container running in the node or a pod, will have to be in the cluster, and only then will the user will be able to access it. This is usually the default setting, that if you don't define any service type, this is where it defaults to. And this is the ideal case where you will not have access to the container that you are running outside of that particular cluster. Kubernetes cluster. Node port is something where you have a node port. So every single node gets assigned a different IP address and a port as well. So it might open a port on all these several nodes, and the traffic that is coming from outside, if you can observe in the diagram, the traffic here is from inside. So this is kind of inside of the cluster. This traffic is sorry, coming outside of the cluster, where you can expose your internal containers outside of the cluster. This still has to be inside one network. So the user over here has to be within the network. Load balancer. Load balancer type is kind of a service where it is usually used for, the name itself defines as the load balancer. It will auto assign requests to the pods that are there, balancing whatever load is coming to the server. External name. This is kind of a service where it exposes your container to the external world with custom domain names, with the CNAME. You can directly add it over to the domain name, and you'll be able to access your pods, your containers through external name services outside of your Kubernetes cluster and the real world as well. Next question was about innate containers. This is kind of a very basic question, and has a very basic answer. Explaining, the innate containers are the containers that start before the main application container. So if this is kind of the main application container, the innate containers will start first. After the initiation and completion of the init containers, only then will the main application container start. My question again would be to all the curious learners. Why do we need an init container? Because if the application container is running, right, we have our application running over here and everything is set up over there. Why do we need a init container that needs to be running before the main application container? Why should we have an init container? What can be some use cases? Any of you can share your ideas. If there is init container, yeah, Arun, you're absolutely correct. So suppose there are some dependencies your application has. Suppose your application needs a database connection that needs to be established, or your application needs a schema to be created, or needs to check that every dependency that is needed is properly there or not. In that case, init containers are required. It will have the purpose to perform initial task or setup procedure that are not present in the application container image. So why do we do like that? For a lot of security reasons, we do not include a lot of security aspects like the database connection checking, and a lot of dependency checks are not added in the main application container due to security reasons. Instead, an init container is created. Once the container loads and it is successfully loaded, only then is it is after the kubectl knows that it is completed, only then it will go and launch the application container. Any mishappen over the init container will not allow the main application container to start. um, list some. The next question says list some security measures that you can take while using Kubernetes. So I have listed out 7 particular points over here, which is kind of the overall security measures that you need to be checking. In an organization, if you are still working on a real project or as well, these are some of the pointers that you should be working on. RBAC is known as role-based access control, where every single user needs to be having a role, and the access should be assigned to that particular role accordingly. So several other roles should have several other authorizations mapped, and this way we have control over the Kubernetes clusters as well. Network policies, this will we will be covering network policies in the last slide. I guess there's a question for this as well. So network policies are controlled pod to pod and external communication. So pod to pod communication, when should a communication happen and when the communication should not happen, is controlled by something called as network policies. There is this document which says that, okay, you can communicate with this pod, you cannot communicate this with pod. With this will have a network segregation over the pods that are running. Container security, as mentioned in the Docker section by Meera as well, image scanning and secure runtimes are very necessary to see. Image scanning is again the process to uh, check if the image that you are downloading, at the last you are actually running a container itself, right? So if the container image that you are downloaded or you have pulled, is that image secure, is that already compromised? So if you go to the hub, if there's a verified tick, which means that it has been verified with scanners and stuff, and it doesn't have any issues. Secret management, we'll be covering this as well. We have a question for this. The secret management is again managing your secrets with username, passwords, configuration, uh, keys, tokens, and stuff like that. Auditing and logging. This is more of a post Kubernetes handling phase, where you need to keep monitoring of all the things that are happening in your Kubernetes cluster. Update and patching. Maintain components and note current versions. So every component that are used, right? Even Kubernetes keeps it updated with new features and new stuffs and maybe security patches. So you need to be sure the cluster that you're using, Kubernetes version that you're using, is updated and patched. Third party security tools, this is something that kind of goes for a automated scanner part, where you can refer to kube audit, kubesec, Kubebench. These are some of the tools that you can use to scan your entire cluster for any configurational issue and stuff like that. Let's cover namespaces quickly. Namespaces, it is the same as defined in the Docker. So we have different namespaces over here. So when you directly first build a pod, so suppose you have an application, you have deployed that on a pod and you have running that. That will directly go to the default namespace. So there are several different namespace, and namespace are an uh, kind of this should be used. It is a recommendation that namespaces should be used to have segregation. So consider this as your home, as anyone cannot enter your house, right? It is not permissible. It is prohibited to enter your house. So likewise, dev namespace, QA namespace is something that other people can't come and edit any of the pods or make any other changes on that particular node. The default is accessible to anyone and everyone that is visiting your cluster, and it is recommended not to kind of host everything to your default namespace. Instead, have several different namespaces created, which will have segregation between the containers and the pods that you are running. Next, we have uh, what are network policies as defined? Network policy in Kubernetes are a crucial tool for securing your application. They allow you to define rules on how you can control your how groups of pod to communicate with each other. So let's look at it with a diagram. So this is how a network policy looks like. So you have to define it as kind network policy. This is kind of the name that you can give, any name that you want. You can give it. So there are this different names, right? So this says, the policy over here says match name database, and from the ingress controller only select the pod that has the name backend. So suppose there is a backend pod, and this is the front end pod. This is the database where the crucial data is being stored. So when the when this particular network policy is assigned, the network policy will only allow connections from this particular node, which is the backend, to connect to the database, and not from the front end. So if the front end a pod is trying to connect with the DB, it won't allow it for the connection. So Kubernetes has this feature for network policing, even if you have namespacing. So this is kind of a very common mistake that is done by developers, that they consider that if I create these kind of namespaces segregations, the dev namespace won't be able to communicate with default or something like that. But only namespaces segregation is not important. It's not what is ideal. You should also have network policies assigned, that it makes sure that only assigned persons, assigned pods or containers can connect to the backend database containers. I guess this is the last question for the session, which is again a very crucial part. This is something that we encountered. I encountered this last year while my research on one of a very big company which hosts Docker and Kubernetes, which had their entire Docker Kubernetes cluster, entire cluster compromised due to this one single mistake that they did with config maps. So Kubernetes has this config maps and Kubernetes secrets. What are the difference between config maps and secrets? Config maps is a decouple configuration architect. So what it does, it will directly allow your credentials to be stored like this. So here, if you can see, this is a Kubernetes component for config map. The kind is config map, and the username and the password is directly stored. This is similar to the configuration files that we might have for web or any other thing, right? This is stored in plain text and can be readable. So this is not ideal. This is what that company did, and it was a very bad situation for them. Instead, what Kubernetes offers is Kubernetes secrets. This should be something that is ideal and should be used. Kubernetes secrets is defined with kind secret, which will have the username and password in an encrypted format. You can choose this as well, and whatever encrypted format will then be used in the main container or the pod. So it should be taken care that instead of using config maps, Kubernetes secrets should be used. Also, guys, we have summarized some resources for y'all. Especially, we had a webinar at Payatu for maybe or the Docker mistakes that are done. We had a demo on the same. You can check it out on this particular YouTube link. We have a Payatu blog as well, which is running, which has Docker security and Docker daemon and a lot of deep dive stuff that you need to be aware of Docker security. If you are starting into Docker and Kubernetes security and want to understand a fundamental and basic from it and want to have a very firm foundation, I would especially recommend Abhishek Vermala YouTube channel. You can just search his channel on YouTube and search for his Docker and Kubernetes section. It is very helpful. It will clear out all of your fundamentals with a practical demo as well. You can also refer to the IBM Technology YouTube channel as well. Labs to play and practice your skills would be Kubernetes Goat. You can find it on GitHub. Play with K8 as you can look around Kubernetes clusters, how pods are getting created, how each pods are talking to each other, how you can restrict pods from talking to each other. These are some of the medium blogs you can follow out, especially Madhukula. He's an ex-bandit. He has created this Kubernetes code. You can refer to this particular lab as well. CIS benchmark, also mentioned by Meera. This is kind of a security standard that most of the organization use. This will have every single configuration that needs to be there, and uh, tools like Kubebench, Dockerbench actually work on the CIS benchmark on checking on with the CLI on if the correct implementation of the configuration is done or not. THM umbrella, OAPS, Docker and Kubernetes can also be referred. You have a Kubernetes 101, which will guide you through the Kubernetes fundamentals and components of it. Methodology on Docker and Kubernetes security. These are some of the ones that are having a basic security best practices that you can kind of a methodology that you can follow. Also, as Meera mentioned, stay tuned, guys. We are working on a very comprehensive methodology which has an internal as well as an external point of view on attacking and exploiting Docker and Kubernetes separately. So we'll be actually seeing what commands and everything from an external as well as an internal perspective. Also, post exploitation reporting and all those stuff. We are soon going to launch it on our Pi2 blogs as well. So stay tuned there as well. I guess that was it. We are now open to any live questions that we might have in the chat.
Yeah, so just like we had a talk about the Docker swarm, right? So from there also you can have this, you can just change some configurations and add a particular IP address or subnet IP provided to it. If you just wanted one container to have remote access by external person, and if you want to neglect it from other containers, right? Even if it's in a same kind of a, even if it's in a overlay network.
To add to this, this question was asked by Sanket. Sanket, this will also help with the network policies mentioned by Meera and me as well on both the topics. So you should have a network policy that will isolate all the containers from each other, which will help you give remote access. And You can have network policies set as well. So that is the sole purpose of network policies, which can allow you to separate different containers from not accessing each other. And still you can give remote access to the container that you want people to have access. We have one more question, Mira.
Yeah, so is it safe from a security perspective to execute user input within a Docker container that is sandbox using tool like NSTL or similar technologies? Still, no, it's not good because even though it's a sandbox environment, still we never know whether we get access from anywhere, even if host is compromised or any other containers being compromised and then take over. There is another question from Dave. So would you like to cover that, Samuel?
Yeah, sure.
About the Docker Swarm or Kubernetes? Which one is more preferable?
It's a great question, Dave. I was gonna come on that. So Docker Swarm and Kubernetes, right? You'll might have noticed that both were mentioned as orchestration tool, meaning both are managers, both have managing capabilities for containers. But Kubernetes is preferred more than Docker Swarm because of its comprehensive features that Kubernetes offer, like auto scaling and auto healing. So suppose if your container is pod is container and your pod is going down, Kubernetes will take care of re-initiating that pod again with whatever rules that you have defined. But Docker Swarm won't have this feature. This is just a single example. But if you ask me what should be preferred, if Docker Swarm or Kubernetes orchestration tool, I would definitely suggest you to work with Kubernetes, as it has a very large scale of features to offer.
I guess there are not any more questions left. Samuel. Okay. Thank you guys for being such wonderful participants. Um, Thank you, Samuel and Meera, for helping the participants with all their questions. Thank you so much.
Thank you everyone for joining. Yeah,
Yeah.
Good night.
thanks. Thanks,
Thanks,
Aparna.
everyone. Thank
Thank
you.